5.3, properties of logarithms. Guys, there's a lot of different properties of logarithms. Okay. We're going to be able to take a logarithm and expand it, or take an expanded logarithm and compress it by using these properties. We're going to use one called change of base. Back in the old days, we were lucky to even have a log button on the calculator, and the only log button that we could use was log base 10. So if I was wanting to take log base 3 of 7, I would have to convert that log base 3 of 7 to log base 10s. Okay, and change of base is really, really simple. We're going to use properties of logarithms to evaluate or rewrite log expressions. Use properties of logarithms to expand or condense log expressions, and use log functions to model and solve real life problems. So far, 5.1 and 5.2, how are y'all feeling this week?
There's a few questions on 5.2 that I don't
Okay. Okay, so a couple of hiccups possibly that we need to overcome, but for the most part, it's going all right. Perfect. So change of base. Change of base is pretty simple. If I have log base A of X, look at it. In relation to the X and the A, which one's high and which one's low? Log base A of X. Which one's high, which one's low? X is above the A, right? So to change that to base 10, I would write the top one. I'm going to go to log base 10 right here. Log X divided by log A. That's it. I changed the base. So what happened here, I started with base A, and here you can see that I changed it to base 10. How do I know it's base 10? If you don't see a base, then you understand that it is 10. Okay. Over here, I can change log base A of X to any base that I want. I can change it to log base B of X divided by log base B of A. As long as those bases, once you change the base, are the same, the number that's higher than the other goes on top, the number that's lower than the other goes on the bottom. It's that simple. And I can also change it to natural logs, same way. Natural log of X over natural log of A. That's change of base. Okay. Questions on that? One way to look at the change of base formula is that logarithms with base A are constant multiples of logarithms with base B. The constant multiplier is 1 over log base B of A. This statement makes no sense to me. If y'all figure it out, get with me. Let's talk about it. Okay. So let's rewrite log base 4 of 25 using common logarithms. Write it down. Write the answer. Write the answer using common logarithms. What's the base of the common log? What's the base of the common log? 10. All I'm saying is rewrite this using log base 10. It's very simple. Don't overthink it. The number that's above the one number goes on top. The number that's down low goes on the bottom. It's that simple. Where's the word? Where are the logs? You got to see logs. It's that simple. It's that simple.
I don't know. I haven't been here Monday, Tuesday.
Doesn't matter. You only have to know what we talked about today to be able to answer that question.
How do we know that it's like base 10? Like,
Do you see a 10 right there?
no.
Then it's base 10.
Oh, okay.
This right here, this might be the question you're asking. If you see common log, that means base 10. Common log means base 10. What'd you write? Log 25 over log 4. That's it. Okay. So now that you've written as log 25 over log 24, you can type that in your calculator. Some of you already typed it in your calculator. If you type log 25 divided by log 4, press enter, you're going to get about 2.3219. Now, before calculators, we actually had tables we had to look these up in. So if I wanted to know the log of 25, I would look at my table and say, here's log. I'd go over to 20, down to 5, and it was 1.397. And then for log 4, I'd say, okay, log, go to 0, down to 4.02. I would write those down. And then I would take my calculator and type 1.397 divided by 0.602. Enter, and that was the answer. Okay. Yeah, and we spent a lot of time memorizing tables. No, we did not. Okay. Now, the neat thing about the calculators you have is you can actually do log any base and go right to the answer on the calculator. Have you ever figured that out yet? Yeah. How do you do it? If I wanted to type log base 4 of 25 on the TI-84, how do you do it? You go math, you go all the way down. Is my calculator over there? Oh, there it is. Math. So log base 4 of 25. Okay. I mean, so y'all have it easy. Like I said, when I started doing logs, we didn't even have a log button on the calculator. We had log tables. And later on, they invented the log, the natural log. No, I'm sorry. They did natural log and common log at the same time. All of a sudden, log buttons and natural log appeared. So, questions on this? Okay. You know from preceding section that the logarithmic function with base a is the inverse function of the exponential with base a. So it makes sense that the properties of exponents should have corresponding properties involving logarithms. For instance, the exponential property a to the u times a to the v is equal to a to the u plus v. We know that, don't we? When the bases are the same, what do you do to the exponents? You add them, right? So the corresponding log property would be log base a of uv. So here, I'm going to say it this way. The log of a product, uv is a product, right? The log of a product is equal to the sum of the logs. Okay, log of a product is equal to sum of the logs. So let's look at several properties. Here we go. The product property says the log of a product is equal to the sum of the logs. The quotient property. The log of a quotient is equal to the difference of the logs. Can you see that? Notice that the u is on top and the u is a positive log. Notice the v is on the bottom, so the v is a negative log. Okay? I'm about to complicate this in a second, but it's really not that bad. Power product. If I take the log of something raised to a power, I can actually take that power and move it to the front and multiply it by the log. So here I'm going to do a quotient property, and it's going to be a combination of the quotient property and the product property. Here it is. And I'm going to do it just base 10. Because I'm going to be I don't want to write the bases, it'd be a little bit lazy. If I had the log of A, B, C divided by X, Y, Z. Do you see a product on the top? Yes or no? On the top, what's being multiplied? A, B, and C. Do we have a product on the bottom? X, Y, Z. But they're on the bottom. So they're all going to be negative. The A, B, and C, they're on the top, so they're going to be positive. So I'm about to expand this. This is equal to the top stuff. Log of A plus log of B plus log of C Now what about the bottom stuff? Minus log of x minus log of y minus log of z. There you go. I fully expanded it. Okay. And you're going to see stuff like this in your homework and everything. So. Questions so far? Write each logarithm in terms of natural log of 2 and natural log of 3. So we're going to use those properties and rewrite these. Natural log of 6. Well, how could you rewrite 6 using only 2's and 3's? Okay, so would you agree that the natural log of 6 is the same thing as the natural log of 2 times 3? Yes. How would you rewrite this using the property we just talked about? Natural log of 2 plus the natural log of 3. Folks, it's that simple. B. I have the natural log of 2 divided by 27. Look at the numerator. Can we express the number 2 using only 2's and 3's? Okay, so we're done. Look at the bottom. Can you express 27 using only 2's and 3's or some exponents? Three what? Okay. What if someone else decided I'm going to write that as natural log of 2 over 3 times 3 times 3? Same thing. Okay, so let's look at both of these. Natural log of 2 divided by 3 cubed. How would we expand that? I'll do this one in blue. Natural log of 2, natural log of 3 cubed, okay? One more step. Move the exponent to where? To there or to here? To here. Perfect. That is correct. What if a person did it this way? I'm going to underline that one in red and I'll work that in red. Expand that. Can you do anything with minus natural log 3, minus natural log 3, minus natural log 3? Combine them. So what do I have there? Does that make sense? Yeah. Okay. Which way is better? Whichever way you understand, right? Okay. How y'all feeling? Okay. Yeah. If you're screenshotting, go ahead. I'm about to erase this text. Okay. Gone. Here's the book working problem A. And they worked problem B. Exactly what we did. The properties of logarithms are useful for rewriting logarithmic expressions in forms that simplify the operations of algebra. This is true because these properties convert complicated products, quotients, and exponential forms into simpler sums, differences, and products. Now we're going to expand. So we're going to go right the opposite of what we were doing. Okay. Expand. Now this is what we were doing. Expand log base 4 of 5x cubed times y. What would we do?
For the first one, you could do log 5x cubed y over log of 4.
So you're wanting to do a change of base and convert it to base 10? I could.
No, then you would have it in the log.
I mean, I could do a change of base on this. What am I taking the log of? Okay, I'm taking the log of the 5, the x cubed, and the y. Okay. Can we break that up? Without changing base, can we break it up? What would it look like?
5 times x cubed times
I need some logs. Log base 4. Log base 4 of 5. Y minus. Okay. Plus 3 log base 4 of x plus log base 4 of, okay. I have a feeling when you're doing homework on these, you're going to miss problems because you're going to forget to put the base down. Okay. Yes. You got to push the right button. Part B. What do we have going on here? I'll kind of be shocked if y'all can rattle this one off. Is this an equation such that I can multiply both sides by 7 to make it fair? You can't just multiply, you know. I would love to take my bank account and multiply it by 7, but the bank won't let me.
Just do a little bit of half.
Okay.
I mean, you can.
I can what?
Do that, but it's illegal.
Yeah, it's illegal. Yeah.
The natural log square root of 3x minus natural log 5.
No. Mm-mm. What's another way of writing a square root? What about the 1/2? Okay, so could I write this as natural log of 3x minus 5 to the power of 1/2? Can I do that?
Yeah.
Y'all good with that?
So what comes out?
Okay. What about the 7? Minus. Okay. Perfect.
3x times 1/2.
Let me think about that for a second. One step at a time here. So I can move a power to the front, right? So now I've got 1/2 times the natural log of 3x minus 5. Is that expanded? But that would be combining. I could combine that back to 1/2 natural log of 3x divided by natural log of 5. But I think that's more combining. I think as far as expanding goes, I would probably stop right there. I'll look at what the textbook does in here just a second. But I feel pretty happy with those answers right there. I'll go ahead and zap it. Part A, is that what we had? Do what?
Oh, wait.
This is part A. Is that what we had? Log base 4 of 5 plus 3 log base 4 of x plus, okay, good there. Part B. Is that what we got? Yeah, because it said to expand. You know, I mean, yeah, I could see a person saying, well, the natural log of 3x minus 5, I could rewrite that, but questions? Okay. One method of determining how the x and the y values for a set of nonlinear data is related is to take the natural logarithm of each of the x and y values. If the points when graphed fall on a line, then you can determine that the x and y values are related by the equation natural log of y is equal to m times the natural log of x, where m is the slope of the line. Okay, we're about to do this. The table shows the mean distance from the sun, x, and the period, y, which is the time it takes the planet to orbit the sun, for each of the 6 planets that are closest to the sun. In the table, the mean distance is given in terms of astronomical units, where the mean distance of the Earth is defined as 1. The period is given in years. Find an equation that relates y and x. Okay, let's use our calculators here. Let's enter this data that you can't even see. There it is. You probably still can't see it. How do we enter this data? Stat. Okay. Edit. Okay, so we will put the x values in L1, we'll put the y values in L2. Y'all good with that? Okay. What I want to do right now is I want to look at this data on my calculator. I want to see these points and see what it looks like. So these are statistics, and we want to create a scatter plot with these. Do y'all remember how to do this part? Okay, I need to go to stat plot, so second y equals, and by default, everything is turned off. So number 1, let's turn it on. It's not on, it's currently off, so I'll press enter in the on. Okay, not a problem. Second, stat plot. Got me to this screen here. I can choose one of these. I usually just mess with number 1, so press enter on number 1. Okay, so make sure that off is not highlighted. So now my on is highlighted. I'm blinking because that's where my cursor is. Type, the first one is a scatter plot. That's what I want to see. My x values are in L1. My y values are in L2. And I'm going to make a little square for each point. I'm happy with this. Okay, if I press graph, I see those points. Do those points appear to be a straight line? Okay. Let's kind of make it so we can see our data better. I want that data. I want my entire window to show all of my data. So if you go to zoom, look at number 9. Zoom 9 will zoom so that your window shows all of your data. Now, let me ask a question again. Do these points appear to be in a straight line? Okay, do you see the difference on how zooming out, we got a better idea of what it looked like? Okay. What this means, let me go back to the previous slide here. Right up here. One method of determining how X and Y values are set to nonlinear data is to take the natural log of each side. So as we look at this data does not appear to be a straight line. But what if I took the natural log of all of the X values and I took the natural log of all the Y values? Guys, that's a lot of work on the calculator, isn't it? I'm about to show you something that you can do in your calculator you've probably never done before. Go back to stat. Edit. I don't want to change my data. Okay. What I'm about to do is I'm about to use L3 and L4. So pay attention up here. I'm going to arrow over to L3, but I don't want to actually type anything there. I'm going to arrow up. Okay. I want this column to be the natural log of this column. Y'all with me? So now that I'm set at L3, I'm going to type natural log. What am I going to take the natural log of? L1. So second 1. You can close it if you want to, but you don't have to. I'll be lazy, press enter. Okay, that, folks, is the natural logs of all those. So I just took the natural log of X's. Okay, so what are we going to do in L4? Take the natural log of all the Y. So what do? I arrow up to the L4 and I type natural log second 2. Enter. Okay. When I did a scatter plot of L1 versus L2, I've got something that was not linear. What I'm going to, since I have taken the natural log of L1 and L2, will I get a straight line plotting L3 and L4? Okay. If you're not with me, let me know right now. To get a better model of the data. I mean, that's it. That's the reason. Okay, so let's go back to stat plot. Second stat plot. Let's go back into number 1. Where is my new X data? Okay, so go down to X list and change that to L3. So second 3 is now L3. My new Y value is in second 4 for L4. How do I make sure to see all of my data on the screen at once? Zoom stat, which is number 9. How does that data look? Straight line. Okay. So what we're going to do now is we're going to come up with the equation of this line. Do you remember how to do that? First of all, do y'all remember how to turn diagnostics on, or even diagnostics on even means? Press mode. By default, anytime a calculator is reset, your diagnostics is going to be turned off. Down here it says stat diagnostics, turn it on. And we'll look at it, what it does for us in just a minute. So I'm currently flashing on, press enter. I have now turned my stat diagnostics on. Let's go back to stat now. Do a calculation. We know that L1 and L2 does not make a line, right? But we think L3 and L4 do make a line. So let's do number 4, linear regression. Where's our X data? L3, Y data, L4. They might ask us questions about this. So do you remember how to store that equation? Okay, I'm going to store that into Y1. The easiest way to put a Y1 right there is alpha trace. Enter. You don't have to do that, but anyway. Go with me. Okay. Look at your R value. 1. Okay. That tells me that the data in L3 and L1 is a straight line. In fact, every one of those points are pretty much on this line. What's the equation of this line? Y equals 1.48x plus, what is that?
Very small number.
Essentially 0. Did we have a point that looked like it was at 0, 0?
Yes.
We did, didn't we? If you do that zoom 9, isn't there a point right there? Oh, by the way, the graph's there already too. Okay. Okay, so we went through the process. Let's go back to the notes for a second. So we looked at this data, we analyzed it, we determined that the data was not a straight line. We took the natural log of x and y, we plotted that data, we did get a straight line, correct? Okay, let's move on. Here is what a small picture of the original data looked like. This was not a line. Here is the data after we took the natural log of all the x's and the y's, and that's what we have in our L3 and L4, right? Okay. Plotting those points, we got this line. The slope, that was A. What was the slope on your calculator? 1.49. That's approximately 1.5, which is 3/2, right? Okay, but we're not going to say the equation of that line is y equals 3/2 x plus 0. Because y is not y and x is not x. Didn't we change our x's and y's? X became natural log of x, y became natural log of y. So the equation of that line, oops, I need to scroll down instead. The equation of that line is, instead of y equals 3/2 x, the equation of that line is natural log of y plus 3/2 natural log of x. All righty? And that is the end of 5.3. I have decided that with the number of people that'll be missing school the next couple of days, I am not going to even start 5.4. We weren't going to finish it this week anyway. I'm going to give you all of class tomorrow and all of class Friday to be working on these 3 assignments. Y'all good with that? So 5.1, 5.2, and 5.3 are due when? Sunday midnight. Okay, let me stop the recording. Don't log off. It makes it hard for me to stop the recording. I understand.
We don't want